All right, let's fire this thing off. So, good morning, good afternoon, good evening, and welcome to the Rise Up podcast. Today, this is going to be our defining episode. And so, what we're going to attempt to do is actually define some of the words and phrases and concepts that get thrown around out there. And of course, every time I start thinking about how do we define things, I always remember, boy, sometimes it's simple things like furniture and toys. Those are very difficult for us to define. And I'll just going to channel my inner Potter Stewart. He was a U.S. Supreme Court justice. One of his popular phrases is, I know it when I see it. So I think it's more going to be around it's maybe not a definition, but we're certainly going to give some characteristics around a lot of the terms that get used a lot, especially within digital transformation, Industry 4.0, and the like. So today, I'm joined by a gentleman named Tom Hollingworth. I'll let him make an introduction himself, but it's his first time on the podcast, so very excited to have him. When I was first introduced to him, it was described as the leprechaun riding on the back of a unicorn, or a leprechaun riding on the back of a unicorn. So, Tom, with that, tell us a little bit about who you are.
Yeah, hey guys, Tom Hollingworth here, mechatronics engineer. As you'll probably hear, Australian, but I am based in North Carolina. So I've been with Rhize for about 6 years now, implementing projects and services in that layer 3 space. I was previously a controls engineer doing like PLC SCADA stuff in a lot of high compliance industries, so animal health, specialty chem, nuclear medicine, those kinds of industries. So basically today I help manufacturers develop and help them develop a standardized data foundation really to enable citizen development, operational excellence, and execute on use cases today. So yeah, a little bit about me.
And I would say it's not just the integration of the level 2, level 3 systems. It's a rich knowledge base around data analytics, because you were doing some instruction for some of the products that are out there as well. So
I did a lot of seat stuff at one point. Bit of a seat trainer there in Australia for a little bit. So yeah,
excellent. Well, Tom, great to have you here. Glad you were able to carve out some time and spend some time chatting about some things. So let's get on with it. So one of the very first episodes we did here on the podcast is we made an attempt to define the unified namespace, and I would say that what we're going to do today is going to maybe be an extension a little bit of that. Just from a socialization standpoint, it's, we look at it, it's an approach for an event-driven architecture. It uses a pub/sub technology, and it also includes a data ops tool that defines the data models and the topics where that information is going to be exchanged. So, even in that definition, there's some things we want to get to and talk about of what exactly does that mean. But when we start talking about unified namespace, the first thing that tends to come up is this concept of a broker. So when we say broker, what do we mean by that? Is it we just MQTT broker, or is it that it's something else there, Tom? So, let's talk a little bit about a broker. It's usually, it doesn't necessarily mean having less money than somebody else. There's something else, right?
I mean, usually it wasn't, you think financial broker, right? Or some sort of, making markets or something like that. But no, in manufacturing, I think we think about events in manufacturing. And we think about someone sort of brokering those connections and facilitating a lot of those messages between systems. So, I mean, typically today it's what MQTT seems to be the flavor. But you could probably consider, with a really simple definition like that, you could probably consider something like OPC-UA. It just equally as, it could just as well be a broker as well, right?
Yeah, I mean, it's really the broker. It's just instead of brokering dollars, it's brokering information. I would say that it's MQTT is this most popular flavor, especially for the OT space. But there's DNP3 in terms of different protocols. I know there's AMQP. That's not as prominent. That's I would characterize that more as a proper message queue. And I mean by proper message queue is, relative to MQTT, it's basically the relationship is between the client and the broker, but there's really no way to guarantee message delivery or anything like that, which in some applications, like telemetry data, that's perfect. But for something else where I want to guarantee delivery, then I'm going to have something that's going to ensure that took place in a message queue like AMQP, or at least that protocol in that context certainly makes sense. So
it's got a lot of parallels to what I'd call like an enterprise service bus. If you think about early 2000s IT, right? I did a project with Tipico EMS, Enterprise Message Bus, I believe, where you've got all these different protocols, whether it be like XML or REST or something like that, all going onto the bus. And these enterprise service buses would transform those messages and deliver it to consumers, certain producers to certain consumers based on different rules, occasionally doing, even protocol conversion. So I see a lot of similarities from that sort of enterprise architecture space into like the broker and what we talk about today with the UNS.
Mm-hmm. Perfect.
We got some other parallels as well from like bottom up as well. When we think about MQTT being the UNS, and you got these like topics and structures. It's almost as if you're taking your PLC controller tags, right? That sort of, I guess you'd call it like tag pub sub, right, within a controller, and then exposing that to the enterprise.
Okay.
Perfect. It's that same sort of thinking of a structure of topics and tags, and bringing that out.
Yeah, I think really when we start talking about broker, we just, I think the important thing to remember is just make sure we all understand the context there of, generally speaking, I would say we're probably talking MQTT, but there's other ways that broker can be used. And that's one of the biggest fallacies of communication is assuming that the other person understood what you were saying. I think that comes into there. I might be butchering that. I think there was a really smart person that said something along those lines. I certainly want to give due credit where that is, and I'm butchering it. So with that, one of the things we talk about within data ops is that we're going to be sending this defined payload structure, and sometimes we call that a schema. But I think there's a lot of different words or ways that you can use schema. There's like the database schema. There's a payload schema. What do we mean? What do we mean by schema? What is that word? Can you?
Usually we're trying to describe. It's usually language specific, as you sort of cottoned on, right? Database schema. Maybe there's a transport schema, or like a JSON schema, or an XML schema. It's usually very language specific and defines the sorts of properties, fields, and attributes that should exist within a given blob of data. I guess you could say that data could be an event, or it could be stored on disk in the context of a database. So when we talk about schema, it's really around like, what is the data structure that we're talking about, right?
So it's kind of the what information am I going to hear? So going back to like a JSON or even maybe an XML, there's the key. What's the property that's associated with it, and there's the value of it. So it's that key data value pair. But you can have a ton of things that are in there. XML is kind of the same concept, but I think it's also much like broker when you're talking about schema. Are you meaning the schema of the data that's flowing, or are you talking the schema that's at rest? And you did certainly present that a little bit, but the database. Go ahead.
In general, maybe it would be like the storage structure, right? Whether we're storing an event and how that packet of data is stored, right, in bits and bytes, how it's physically stored and organized in a particular system or database.
Yeah, and in the database schema, it's the we're looking at, you have a table, you have primary keys, foreign keys. What's the relationship of everything, and how does all that fit together? And certainly in that context, it's important to understand that when you're going to retrieve information, having that understanding of the schema and how all that data relates, that's where it's going to come in important, that type of thing. So so schema is, we're going to have a broker, we're going to publish a schema, probably a JSON payload through that. But, one of the things that we talked about on our last, go ahead. You have something more you want to add there?
There are a lot of other things that we talk about when we say broker. We did touch on, routing messages, but things like security, metrics, governance, maybe even describing what schemas should exist in those messages, and potentially even like protocol conversion, right?
Mm-hmm. So that perfect segue right into what I was going to ask is, on a previous podcast, Yoron and I were talking about transactional data, the event data. So you have the event, and then there's some data that's moved back and forth. But let me get into the schema validation, and it's you can probably intuit exactly what that means. But in what Yoron and I talked a little bit about of why that's so important. But when we get into schema validation, I think you already touched a little bit on it, but there's some data governance aspect of that. So what do you mean by that?
So schema validation, basically, we've got this payload of data. Does it conform to our expected data structures, right? The ints between 100 and 200, or are the strings a certain shape of string, right? So it's about defining or receiving something and making sure that it conforms basically to our schema, right?
Sure.
Is this expected data contract? I said, give me A. Is it giving me A or is it giving me B, Z, 1, 2, 3 kind of thing? And it's about checking that there's what they say in. Well, I think there's a couple of different sayings out there, but you can't really trust that the person sending the data is going to always send it in the right format, right? You got to kind of you can hope, right, that everyone's going to send data in the right format and it's going to fit every time. But Murphy's law? I got to think about these things now. What's the one with like user interfaces? If there's an opportunity to break it, they certainly will.
Yeah, exactly.
Escaping my head right now.
And I'm with you. It's there's been some technology implementations that literally there are people that are in these manufacturing and process plants that they've got nothing better to do than see if can I break the new technology, and they're going to go out of their way to do it. And people say, I've been asked that, people will do it. It's like, yeah, they're going to do it, and that's not all bad because it does help your product.
Whatever can go wrong will go wrong, right?
Yeah, absolutely. There's always going to be something in there. We try to think of all the edge cases where that might occur, but and that's why it's so important that yes, I'm using data ops. Yes, I'm defining these payloads that are supposed to be sent, and it's all there. But guess what? Sometimes things get a little wonky. Maybe the source of one of the data doesn't come back, and now you're in trouble.
It's not the known unknowns that'll get you; it's the unknown unknowns that'll get you, right?
Yeah, exactly.
There's cases that you didn't even think were possible.
Yeah, absolutely. There seems like there's a Donald Rumsfeld line in there somewhere, right? So going back to early 2000s. So
schema validation is about making sure that the sender is sort of conforming to the data contract, right? So if we can build a bunch of test cases around our schema, and we know we're receiving data in our sort of format because we're doing schema validation, we can lower our risk for errors happening and introducing bugs into the system.
So another concept that's closer related that I'll hear every now and again after, in the context of schema validation is this data validation. And sometimes I hear them used interchangeably, though I think they're a little bit different. So what say you?
What say me? I say they're pretty similar. Schema data validation sounds like a lot more smaller context than maybe schema validation. Sure. Schema validation you may go a little bit further in one where you're like checking that these relationships do exist. Other times you're just checking that the payload conforms, right? Maybe in messaging, maybe I'm just checking that there is an ID that exists where I'm referencing some sort of equipment or workmaster or something like that. But maybe in the other scenario, I'm actually checking that yes, you've said something there, but yes, that thing actually exists in my system, right? So maybe it's going beyond just the simple, does the payload look good? Does the data look good, right? Is this a valid workmaster I know about, piece of equipment I know about in my system?
Yeah, it's a fine line between them. I mean, you're going to have the schema validation. It's not only going to ensure the right structure, so key values are there. So if you're familiar with JSON formats, you're going to have this collection of these objects and these collections of arrays that are there. So, in ensuring that if you're expecting an element, part of that schema validation is there. Data is also going to, as it starts digesting and processing that information, it's also going to ensure that as you're processing it, that it actually can do the type of parsing of, say, that JSON payload that's there. That maybe the schema was good, but as we start going through the data, there's a problem here. Like, I'm going to have an operations request that's made, and I'm going to ask you to make some product. Well, as I'm validating that data, I'm going to find out, you know what? We don't have a material definition here, so we're going to have to kick it back. That'd be part of that data validation that might occur in there.
Yeah. It's kind of that next step, right?
Sure. Yeah. So it's and oddly enough, whenever we start processing our data, the first thing we do is schema validation. Well, then we do some data validation, just make sure that things are happy, because the last thing we want to do is get noise in the database. So it's easier to keep it out than try to get it out once it's there.
Yes.
That can be a mess.
To make gold, one must start with gold.
Absolutely. There we go. All right. So since we talked a little bit about when you're getting data and you're going to persist data, you want to ensure that it's, in the right format. I think we want to talk a little bit about ontology. And that's a word that I'm starting to hear more and more about. Oh, we need an ontology. So What's an ontology?
Yeah. So an ontology is more about defining the relationships and the meaning in those relationships between things, right? Within a specific knowledge domain, right? So manufacturing, we talk about ontology, right? A classic example I give people when thinking about ontology is a family tree, right? And the relationships that exist in a family tree, right? With the emphasis being more so on like the relationships than the actual, sometimes the entities themselves. So if I were to say I have a sister, you inherently know what I mean by that, right? You know,
Mm-hmm.
it's a person, likely
Yeah.
female, and we're related through parents, right?
Yeah.
So
Yeah.
that's the idea
Common
where,
parent. Mm-hmm.
yeah, common parents. So that's an idea where like ontology is around describing these relationships between the data, and the emphasis is more on relationships than more so how it's necessarily stored, like a schema, right? So a schema is talking
Okay.
about how it's stored, the structure of it, whereas an ontology is this sort of like abstraction above your data that talks about the meaning in the relationships and the entities.
Okay. So
Yeah,
if
I
I
don't
want to
know.
talk about my second cousin, third removed, you know
Yeah,
what
yeah,
that means. That relationship's very clear and well defined
that's
within
it.
the family
That's it.
tree ontology. Yeah.
Like I'm
Very
just trying to
good.
think of an example in manufacturing. Maybe you could say like a test sample has a test specification, or the test specification on that test sample, right? You
Mm-hmm.
may inherently know what I mean by that, right? It's what we're trying to test against, and like maybe it contains the limits of what we expect our sample to be in for a past result, for example.
Yeah, and I think, coming off of the concept of a UNS where you're going to have data that is, the data ops tool, it's not just defining a payload, but as you're adding things as additional intelligence is produced
Yeah,
and consumed, it's that gives you that context. But what you may not have is this ontology of how all this data relates to one another. And I think that becomes one of the fundamental differences. It's mostly when I get into some applications like genealogy and track and trace, it's I might know and be able to add the context of a material lot that's associated with the manufacturing process, but I might not understand the relationship of how did that lot come to be right in this current time, where it came in as a raw product, there was a raw lot, and then it got moved into maybe a sublot, and then it got moved into, all these ways that material can be transformed
yeah.
throughout a process. And I think the ontology helps describe those relationships and that type of thing.
How that works together.
Perfect.
Yeah,
Yeah. So, continuing on with the whole UNS, one of the, as we talked about the socialization, its approach for an event-driven architecture. So I know on
yeah,
some of the earlier podcasts, we talked about what are some of the patterns. I've referenced Martin Fowler and some of these 4 patterns that emerge in there. But when we say event-driven architecture, and I'll even talk about UNS being an event-driven architecture for OT, what exactly is an event-driven architecture?
yeah. It's a good question. Event-driven architecture. Obviously, we've got events, and they are doing the driving, right? It's kind of in the name.
Yeah.
But event-driven architecture. So, one event could kind of fire off multiple events, which fire off multiple events, that kind of thing, right? So we've got a bunch of different applications or systems, or even within the one application, right? Reacting and subscribing to events, and maybe the temperature fires off in Fahrenheit, and because I subscribe to all the Fahrenheit events, I then transform it to Celsius to then publish out Celsius, right? So it's about reacting to those events that get that sort of come about throughout your system, and then firing off other events. I mean, it could kick off a workflow, work orders, all sorts in manufacturing.
Yeah, I think, at least event-driven architecture within the framework or context of an OT environment is that, historically we've always talked about this pull response type mechanism, and the
Yeah,
idea, and this, coming back to the broker that we were talking about earlier, it's that with MQTT, yes, there's always going to be some scanning that occurs at whatever that source is, but unless there's a change that's greater than what we've determined is, yes, we're defining this as a change, now we're going to report that by exception. Well, that becomes that event driven element of we're not going to do anything. There's really no new information here. And we're going to architect that system to respond only to those events. So I'm not going to have all these systems that are going to be interrogating that source of data. We're going to have one thing that tells us. And I think really that's the fundamental piece, at least within the context of manufacturing and OT.
Yeah, maybe it's best described to its alternatives as well. So you gave request response as an alternative. Another one typically is periodic, right? Where maybe the ERP drops a flat file every day of the upcoming orders, right? So as opposed to the flat file coming down once a day, maybe whenever that order is created, it immediately gets sent on to the next system.
Okay.
And conversely, your request response pattern as well there.
Yeah,
Mainly,
and I've even seen a combination of both where you'll have all
yeah,
that. Ultimately, the major event or when that large payload comes through, that's more event driven. So, for instance, I could be doing this poll response, and when that poll gets a response that says something changed, now I'm going to trigger the main payload event, like there is a new manufacturing work order that has just arrived type of thing. But otherwise, I'm just looking for changes, and oh, look, there's a change. Now here's all the information that's associated with that. And, yeah.
Yeah.
So there'll be a combination, and because there's some that I've done where it's both. There's a period where this occurs, or it's just the timer, that type of thing. But ultimately, the big movement is that event. So, with that, there's these two concepts that come together. Going back again to the UNS conversation we had, we spent a little bit of time talking about orchestration and choreography, and I think these are really important in event-driven architectures because orchestration. If you think about an orchestra, which is where it comes from, it's that you're going to have a conductor that is always going to bring a part in. It's going to look at you and say, here, it's now your time to go do this thing, versus choreography, that if I'm doing, say, a dance routine, and I can tell you don't want to see me doing a dance routine, but if for some reason I was, now I'm just looking to see what somebody else is doing, and that's the cue for me to do the thing that I need to do. And that's great because you don't have maybe the overhead of the orchestration, but boy, if I get it off, or if I'm wrong about what it is that I'm doing, that could be bad. So within orchestration and choreography, I mean, how do you use these? What do you see in manufacturing?
So I guess I see a lot more orchestration when it's more data pipelines. And so I guess there's probably three examples of orchestration I typically see. It's either a data pipeline, right? Maybe something happens, we need to grab in some master data, do something else, and then publish something out. Another example, orchestration would be like an MES or SAP, right? Where we've got those standard manufacturing instructions where it's all defined in sort of one system, and we are just orchestrating through that workflow, pulling out to the control system, right, where it makes sense. So, I mean, like I said, I do a lot in sort of high compliance industries, and so orchestration is definitely the probably preferred for certain, for making pharmaceutical batches and things like that. Choreography, I mean, that plays more into the UNS, right, where you're a little bit less governed on what should exist and what data is sort of publishing and subscribing to each other.
Yeah.
So,
and they're both approaches. It's just like everything. It's not one's right or wrong. It's just that there's different approaches you can take for what it is that you're trying to do. And there's risks of not using orchestration. I sort of mentioned it earlier with orchestration. There can be some overhead, where with choreography, there really isn't anything. It's, hey, you just let the system go and hope that it gets there and implement some of the governance that's there. You mentioned data pipelines. What can you talk a little bit about data pipelines?
Sure. I kind of see three different types of workflow in manufacturing. I think there is the data pipeline flow, right? Where we've got data in one system, we're transforming, republishing, that kind of thing. Maybe bringing in an ID schema or normalizing the data into some sort of other format. We've got the sort of the sort of workflow of an MES per se, like step one or SOP, right? That's a sort of workflow. And then we've also got this like process flow about process. So, making your cake example, mix our dry ingredients, mix our wet ingredients, mix them together, put it into like a cake tin, bake, and then decorate or something like that, right? So there's like this sort of three different workflows that I see in manufacturing.
Okay. Yeah. And then just going back on this orchestration piece, you were talking about the workflows. I mean, so I always think about, say, work instructions of, once I get to this step, now here's what I'm going to do next. It's like putting together a Lego, assembly. It's there's my work instructions, if you will. Well, that's that orchestration piece of, you're going to do this. Now you're going to move on to the next piece and do this set. It almost seems like building a Lego something or other would be a great way to demonstrate a lot of what this stuff is.
Yeah.
Cool.
I agree. I mean, you could always think of like choreograph. I'm trying to think of a good choreograph example. maybe the way that some manufacturing sites can arrange their lines are more choreographed, right? All I know is that my bottling line accepts bottles, right? Whatever I plug up to that, it doesn't really matter, right? No one's orchestrating that you must do this machine that makes bottles into the bottling line or packaging, right?
Yeah, I think those
choreographed for the actual order that's being produced.
Yeah, I think those Rube Goldberg machines, or when they set up all those dominoes, you kick it off once and that rest of that thing's choreographed, and you hope to God that the mouse does what it's supposed to do. Right?
Exactly. I usually get a 200th take on how,
Yeah, right. Man, you wouldn't want to get that wrong, but hey, what do you do? So another piece that I run into a lot is, especially in this, Rick Bellotta, he was on for the Uber broker, and we talked a little bit about microservices. And this is one of those terms that gets thrown around a lot. And it's like, I know there's services that run on, servers and they're doing certain things, but now we talk about microservices. So I don't, it's almost like it's just, is it just a smaller service? It's very lightweight, does something unique. How does that fit into this event-driven architecture or orchestration?
It's that whole
choreography.
I guess it ties into choreography and like nodes in the ecosystem, right? So a microservice is a little node that's maybe it's doing a very small bit of functionality, right? What is it? Linux, Linux is built on a bunch of little utilities that do one thing and one thing very well, right?
Mm-hmm. Yeah.
And then it's up to the user then to orchestrate those things together. Similar sort of thing with microservices. You can build a bunch of little applications that up and subscribe, right, to your ecosystem, just that does one thing and one thing really well.
Mm-hmm. Yeah, when we talked about microservices, especially at the edge, it's, if I'm doing some kind of machine learning at the edge every 15 minutes, 5 minutes, it's some period, maybe in this case, it's that I'm going to look to see what's going on. I'm going to run it. And then if there's something that's of interest, then I'm going to do, if the result is true, then go do something, with that result.
Yeah.
Type of thing.
It's the alternative is a monolith is what they call it. And that's basically putting all your code into one code base and then publishing that whole big app. If we could compose our app into little individual services and split them out into different apps, the idea is that you can deploy these little apps individually as long as they fulfill that data contract, right, with whoever they talk to or whatever it needs to do. As long as that data contract doesn't change, you can just, innovate on that one little microservice independently of deploying a whole system, right?
Yeah, exactly.
Also reduces your testing, because now only have to test the interface and the boundaries rather than have to test the system as a whole. So you can get sort of faster innovation through sort of microservices architecture.
Yeah, absolutely. And I think just, really the intent here, and we've talked about it earlier, is it's not bad versus good. It's that these are all the things that you need to consider and think about in every way we're starting to connect data, connect systems. These are all the things that go into it. But I think it's important at least to understand, if it's the microservice versus the monolith, what do those mean? What are the risks? What are the upsides and those types of things? So
maintainability is a big one, I'd probably say. Usually and microservices is a way to, when you have very large teams and teams of teams sort of thing, to sort of carve out a piece of functionality and make a whole team responsible for it, rather than monolith where maybe you've just got the one team working on the one.
Yeah, but it's to your point, if you make one change, then you have to deploy and undeploy the whole thing. You don't get the chance of, whoops, let's just roll back this one thing. It's that can be a challenge itself. So